Hello, everyone. We will start in a second. We'll just wait 1 more minute, maybe. Mm, Okay, so I hope you can all see my screen now. If so, let me start. And good morning, everyone, and welcome to today's webinar. We are thrilled to have you join us for final event in our Roadshow with DIHs series, because we've been running them over like past few months now, and it was quite a journey. And today we are wrapping things up with exciting lineup of speakers who will share their insights with you today on sustainable manufacturing, emerging technologies, and digital transformation. My name is Magda, and I will be your moderator today. We are fortunate to have 6 experts with us, and I'm pretty sure you will walk away with some new valuable knowledge and strategies that you can apply to your own work every day. Before we dive into today's presentation, just a quick reminder, during each presentation, please feel free to submit your questions in the chat, for example, and we'll try to address as many as we can at the end of each presentation or at the end of the webinar. And now here you can see a quick overview of our agenda for today's session. We'll hear from experts on topics ranging from 5G and emerging technologies to zero waste manufacturing and digital innovation. With that, let's dive right in and take a quick look at our speakers today. Uh, those are the leaders in their fields, and they will be sharing their expertise on topics related to, again, innovation, sustainability, and most important, future of manufacturing. So let me start with our first speaker. I will now stop sharing my screen. So maybe Pierif can start sharing his, and I will give a short introduction. Pierif is a senior consultant at 5G AI, uh, I'm sorry, and AIoTI, where he plays a key role in driving the development of smart connectivity networks and next generation technologies. He has a wealth of experience in shaping the future of 5G and its application in sustainable manufacturing. And today he'll share how 5G can contribute to achieving zero waste and sustainable manufacturing goals. The floor is yours.
Thank you, Magda. Thank you, and good morning, everyone. So thank you to be there. So yes, my talk is today, dealing with what so we understood at the 5G, 6G AI, sorry, with regard to the manufacturing and the waste and sustainable. So there are already a number of activities which has been conducted, and I will try to give you some feedback about what we have already done. So, okay, so first of all, so that's more or less, so our understanding, a huge understanding of what is really this aspect, this zero waste management in manufacturing. So there are a number of technologies, obviously, that could contribute to this specific industry 4.0, such as blockchain, machine learning, big data, and so on, but also connectivity. Connectivity is needed not only for the development and the construction of any product, but also during the maintenance and so obviously the use of technologies by end users. That's more or less so what we have identified. Then, so in order to understand well, so this aspect, so what we have understood as well is that so these technologies should be better known with regard to the digital monetary of each individual organization, meaning that if you look to an agriculture or a machine constructor or a car EOM, so you need to better understand what are their needs, and so DIH there has a real great role in order to better understand what manufacturing SMEs needs to take into consideration. And then, so the SNS GU project, so not the 5G, but the further 6G project, are developing technologies and they are testing them, through pilots, experiment, and so on, and with vertical domain. And some are addressing the sustainable manufacturing. So it's what I would try to explain to you. So what is, just in 2 words, what is the Smart Network and Services Joint Undertaking? It's a large public-private partnership with the double mission. First, to foster Europe technology sovereignty in 6G, so how to prepare the 6G, but we also try to, to take into consideration the 5G deployment in Europe, because 5G has been developed so in the last year, and now so we deploy in Europe in the standalone and non-standalone meaning, and so it's important to better understand what is the real use of 5G in order to build on the 6G. And so we also try to take into consideration sustainability in terms of energy, in terms of security, and so on, in order to be in line, with overall European policy. So we are developing a strategic research and innovation roadmap. So, but in order to contribute to the development of the call text, then people or partners could build, proposal and project and run their project, during in order to contribute to the overall development of the 6G. That's more or less, what the SNS is, and so with regard to the case of zero waste management, so I have found this interesting, picture which shows how manufacturers can generate less waste management, less waste in their life cycle, and also contribute to the circular economy, which is key, because we are in our domain developing a lot of devices, solution, and so on, which should be reused more in the circular economy meaning. So, and it's why AI, ML, IoT, 5G, cloud computing, and big data could contribute to this to this overall willingness. So the role of the 5G in the circular economy. So as you see, Industry 4.0 should obviously contribute to take advantage of the circular economy in order to minimize their footprint. And so there are a number of technology which are contributing to that, such as AI, big data, blockchain, cloud computing, cyber physical system, additive manufacturing, but also you have the 5G, which is also, and the further 6G, which is contributing to this as well. So with 5G, manufacturers can monitor the life cycle of their product even after sale, and with 5G enabled sensors. 5G has the possibility to support thousands of sensors, and so it's really one of the key topics that could be used, to provide a better following of product developed by manufacturers. For instance, if you, so that's just a case, an application that could implement 5G enabled smart water system, for instance. So 5G network could facilitate monitoring of water infrastructure. That's a case which has been developed, and so this reduce water waste and consumption and so on. There is also some use cases which could take advantage of 5G, to be better sustainable. Well, so the role of 5G in this domain, first, obviously, it's contribute to so the energy consumption, cutting the energy consumption with a high performance 5G, with ability to harness machine learning and AI. And so this, as I just told you before, this is one of the key objective, not on the 5G today, but on the future 6G. There is a further step, in this domain, because so there is a real mean and need to decrease our footprint due to the fact that so we are consuming more and more energy to store data, because so we are all producing more and more data. So we need somewhere, to decrease so the network consumption. And for instance, one of the possibilities that we have in mind is on the antenna. Instead of broadcasting the signal all around the antenna, so we are trying to target each devices one by the other in order to decrease this overall consumption. That's only a case, but there are several other cases using AI that will normally decrease the network energy consumption. Transport, so mobility connectivity is key, for connected automatic car, but also transport and logistic, which obviously take advantage of connectivity of 5G and future 6G to maximize, for instance, vehicle and fleet efficiency, but also decrease the overall diesel consumption, for instance. Port today, there are already some advanced port use cases which could also take advantage of 5G, mainly with the sensors, for instance, on each product transported by ships, they could be located and followed easily in order to avoid something lost, for instance. Mining, this pervasive 5G wireless infrastructure is also key, for the transition innovation. In autonomous vehicle is what I already told you, but also environmental monitoring, geofencing, massive data collection. There are a number of points. So, for instance, on this one, we have developed recently the destination, or contribute to the destination Earth project, which has the objective, to build the digital twin of the atmosphere in order to predict better weather forecast. So it's one of the use cases that has been developed and which take advantage of smart connectivity. And manufacturing, so the last one, as I already told you, which obviously take advantage of 5G connectivity and future 5G as well. So manufacturing in the SNSGU project. So we have developed what we call the vertical engagement tracker, which is tracking all the use cases developed by a project funded under the SNSGU. So there are a number of use cases which are developing use cases on different verticals. I will show you that later. And so we have built a cartography which is mapping, all this R&D and DFO which address 6G and 5G technology. And so this use case are based on criteria like targeted, so specific vertical sectors, location of experiments, nature of the experiment, and functionality deployed, so that people have a good understanding of what have been done and where they can see them. So, for instance, So I have identified 19 projects funded under this SNSGU, which are developing use cases targeting manufacturing. And 5 of them are addressing sustainable aspects. So there is a Big Green project, which is developing physical environment awareness, Targetix project, which is developing environmental condition monitoring, Time project, predictive maintenance, ExaX project, which is a flagship project, which is developing AI assisted end-to-end lifecycle management, and confidential safety project, which is developing a predictive maintenance for airline consortium. So that is real use case which has been developed. So within the project, targeting this specific aspect. And in order to have to establish a channel between RNI, the SNSTU project and end user through the DIHs, we have put in place what we call the replicability initiative, which is collecting all the use cases developed by project in different verticals and try to give them a level of replicability, how easy it's to replicate one of the other use cases. So there are today, I think there are more than 200 use cases in this database. And so we have developed this replicability assessment tool, which is a questionnaire, which is addressing technical dimensions, data dimensions, market dimensions, acceptance dimensions, regulatory policy dimensions. And with that, we are able, to bring a level of replicability that DH should be able to use to identify which is the best-in-class use cases answering to the end user requirements. And so we have a catalog today that we are trying to enhance, time to time with regard to the project development. And some of them are contributing to the waste objective in two folds. So reusage of RN solution, and some use cases are addressing manufacturing sustainability. Meaning that this initiative is also contributing to the overall objective of zero waste manufacturing. So just to summarize, my talk today. So zero waste manufacturing could be addressed through several technical aspects, what I told you, and one of them is the connectivity, which take advantage of which bring advantage, to help manufacturing in this decreasing a number of topics. So several geo projects are already developed and experimented use case in this field, and so smart connectivity DH, so coordinate members are providing a digital manufacturing level, which obviously help manufacturing to identify key topic, to contribute to this overall objective, and obviously to identify available use cases that they could reuse for end users. So that more or less conclude my talk. I hope I am in time. So thank you for your attention. Obviously, so I'm ready to answer any question if any.
Thank you for that presentation. We really appreciate you sharing the insights with us today. If anyone has any questions, please write them on the chat. If you think maybe later you will have another question or something, also mention that in the comment and we will get back to your question. Maybe I will start introducing I would call it a segment in our webinar and our next speakers. So now I'd like to welcome Maria Paez, who is the marketing coordinator at Funding Box and the product owner of Tech Finders. And today she will be talking about how Tech Finders are helping build use cases for technologies. And also she will be joined by three other of our experts. So she will be joined by Oscar, Thanasis, and Puria. Oscar is a principal researcher at Ikerlan. He has extensive experience in mechanical engineering, robotics, AI, and data analytics. And today, he will showcase ZZW. Thanasis is a research engineer at the University of Patras and the technical coordinator of Regroup. He specializes in optimizing manufacturing processes, particularly in machining, sheet metal forming, and additive manufacturing. And Puria, a 6G expert at Huawei Technologies and the technical coordinator for the Zero Swarm. He specializes in connectivity solutions, 5G and 6G technologies, and green transformation in industries. So, Maria, maybe you can share your screen with the presentation, and the floor is all yours.
Thank you very much, Magda. So I'm going to share my screen. Second. Do you see my screen?
Yes.
Okay, do you see the presentation and it's in presentation?
Yes.
Okay. Cool. Okay, so, well, good morning, everyone. As Magda said, my name is Maria Paez. I'm marketing coordinator at Funding Box Technology Transfer Cluster and also product owner of TechFinders. Today, I would like to introduce this new platform that connects European technology developers with manufacturing SMEs, helping them collaborate to develop use cases and understand their market and gain real insight. And also, I'm going to introduce some of the projects that are already working with us to develop those use cases inside the project and testing the technologies that we are developing between the project in real market scenarios. So before explaining a bit further what TechFinders is, I would like to introduce my team. So TechFinder was an idea of the technology transfer department in Funding Box. Our team of 10, divided in project management, marketing, and tech transfer, provides end-to-end support from bringing new technologies to market. So what we do in the project that we are involved, we assist our partners with go-to-market strategies, offering test before invest opportunities to validate their technologies in the market. We will explain a bit now some of the technologies that we have ready and we are working in the project in order to bring them to the market. So what is TechFinders? TechFinders is an online platform that connects the latest innovations in Europe with potential adopters. So we have a curated catalog of technologies divided and categorized by industry, technology, project, and publisher that they are tailored to the manufacturing industry. So we use a market validation approach and a lean strategy to ensure that these new technologies and these new products are showcased in a way that the manufacturing SMEs can have access to. So this helps a bit to bring the gap between the technology and market readiness, right? So it's a way to, let's say, bring closer those new technologies to the market. So how TechFinders work? Well, working with TechFinders is super simple. So imagine that you are a technology developer. So we create a technology card in our catalog where we highlight the main benefit and features and technical information about the technology. We also create and position yourself as a developer in our European hubs. So we want to create a European developer network when all the developers that are interested in showcasing the technologies can be in one place. So this way we have these two sides of the ways, and once you can promote your technology, and second, you can promote yourselves as a developer in the, let's say, market. So, and then how we develop the technology use cases, because as I mentioned, we work with early, let's say, development. Well, and we work with different technology readiness levels. So depending on the necessity of that technology, we do different, let's say, activities in order to get real insights. When the TRL is low, so the technology is not, let's say, very developed, we start with interviews. We interview potential adopters that help us to understand exactly if this concept and this idea could be like a good fit for the market. If the technology is more developed, it has a TRL 5.6, let's say, we create like demos. These are interactive demonstrations that we showcase the functionalities of this technology. And this also build confidence into those early adopters and showcase exactly how this technology work. And then if we are working with TRLs that are a bit higher and the solutions are a bit more ready to really be tested in real scenarios, we do the test before invest experiments. So with those early adopters that we have inside the project and also outside, because we also look outside, that's why tech founders work, we create these matchmaking opportunities where an early adopter and a developer work together to test the technology. So we maximize their impact in the market and also, support both the innovator and the adopter and every stage, right? This way it's a win-win situation. The developer get real insight about how the technology interact with the market, and also the SME understand the new solution and how they can be applied to their processes. So I record a bit how the website work, just to do a quick demo, let's say. So I'm going to play the video, and I'm going to explain a bit how this is divided and what can you find in TechFinders. Also, my colleagues shared just the link in the chat, so you can also go there and have a look by yourself, okay? And maybe we can talk about later if you have any questions. But I'm just going to play the video, and then we'll see together what we can offer. So this is the main page of the website where we summarize a bit what you can find, the catalog, the solutions, also where our partners are located and how the process works, and also case studies, that is the main value proposition of the tech finders. Then we go to catalog, and here you can see all the technologies that our developer partners are developing, and the filter that you can use to find what you're looking, right? So if you're looking for a specific project or for a specific technology, you can use this. This is an example of a technology, let's say technology card, where we can highlight the information, the benefit, who developed this technology, and where the services linked to this, and also the use cases, if any. And then, as an example of use cases we have here. So this was already a collaboration that we did between an SME and a developer, and they created and they worked together to understand the technology and their real, let's say, use in the SME process. Also, we have the hubs, as I said. So we want to create this wide network of innovation in Europe where we can position our partners in order to create this ecosystem that they can work together and partnership together. And the blog. So we also develop, as I said, when we create a use case, we try to explain, because this is at the end, add value to the technologies, and also some knowledge about the different projects that we are involved and the latest trends and innovation. Okay. Okay, so what do we offer to DIHs, or what do we think that TechFinder could be useful also for DIHs? Because you can use it, let's say, into scenarios. Once, if you are developing some tech solutions between the DIHs and inside, you can have a possibility to promote your technologies on TechFinder, so participate in this wide catalog and this wide network of developers, and find those early adopters. This will help you to understand better your technology and understand if they're actually a fit on the market for them. Or second, even though you're not interested in promoting any technology, you can add value to your SME network by sharing this platform and let them know that these solutions exist and they can look for new technologies in the platform. So as I said, we inside Tech Finders, we have different projects that we are part of, and we do the exploitation, let's say, tasks. So we are helping our partners in the project that are developing technologies to bring them to market. So we are doing test before invest scenarios, and those technologies depend on the project, right? So right now, I would like to introduce to some of our partners in order to let them know what are the technologies that we are developing and what are the possibilities and the opportunities that these projects offer. So first, gonna start with Thanasis from LMS, explaining Regroup. Regroup is developing resilience and reconfigurability solutions for the manufacturing sector, and he will explain the technologies and the solutions that we are developing and when they will be ready to be tested. Then Oscar from Ikerland, he will explain zero defect, zero waste project, ZDZW, that are developing zero defect solutions for a more sustainable manufacturing market sector. And then Cirrus One. Cirrus One will be explained by Puria from Huawei. And this project main goal is to create 5G solutions for a greener and more digital manufacturing. So please, Thanasis, the floor is yours. You can explain a bit what Regroup is. Just, sorry. Okay.
Okay, yep. Thank you for the intro, Maria. So good morning also from my side. Regroup project is funded under the Twin Transition 0101 call of 2022, which was called the Rapid Reconfigurable Production Process Change. And basically this call was a response to the events that happened during the COVID pandemic. So the idea of the call and basically the idea of our project is to address resilience through reconfigurability and digitalization. So for us, that means that companies right now have to operate in a world with different uncertainties, with volatile markets, with complex supply and value chains that make decision-making and information exchange very difficult. And this, and also a set of unpredictable events that are hard to anticipate. So what we want to do as a project is to develop digital tools that give you this ability to anticipate the external disruptions that are relevant for your sector or for your company. Then also develop tools that are directed for the shop floor and help you reconfigure your production faster. And the most important, bridge these two different nature of solutions with a digital thread that supports information flow, helps the collaboration between different departments of the company, and makes the decision-making process during a reconfiguration more informed, reduces the reconfiguration cost and time, and in turn builds better resilience to the company. So we have more than 20 partners in our project. We are a 4-year project. We have 5 pilot companies that you can see here from different sectors, different sizes, different levels of digital maturity, and completely different needs in terms of reconfigurability and resilience. If we move on to the next slide, we can see how all these different tools that I mentioned can be grouped into 4 different suites, which address some types of reconfigurability needs and pillars. So first we have what we call the Regroup modular suite. This tries to target the increase in modularity of production assets, and here we have modular and reconfigurable molds for injection molding that can support companies to very easily reconfigure between different product mixes depending on their demand, and also test different product designs in small scale productions without the need of large investments, so with a minimal penalty in reconfiguration time and cost. We have also the Regroup multi-level monitoring suite, where we have inline monitoring and quality assurance systems for a wide variety of processes that we incorporate in our projects, and these can range injection molding, laser-based processes, metal extrusion, plastic forming, metal forming, and so on. So these tools also, apart from getting production data and ensuring production quality, also have the target of being reconfigurable and easy to transfer between different companies and applications. We have our digital toolkit, which is basically a set of digital twins for the many processes that are supported with in the project that I mentioned before. And then we have what we call the production organization suite, which is it can be grouped into three, let's say, subgroups. We have tools again dedicated to the shop floor, such as planning and rescheduling algorithms. We have also tools that are focused on the human part and the human nature of the reconfiguration. So we have a lot of end users in our projects that are heavily involved, that the processes are heavily dependent on human personnel to be executed. So we have adapted digital work instructions that can help operators accommodate the reconfiguration process more easily and reduce their cognitive load. We also have tools that are dedicated towards the management levels of the company, where we have tools that support high-level strategic decision-making. We have tools for sustainability analysis regarding the decisions that manufacturers take on production and how changes in design can impact the sustainability of the production. So this helps also the collaboration between the manufacturer and their customers who design the products. We also have tools for digital twinning of the supply chain, and also for capturing of weak signals that can help you anticipate potential shifts in the market that might need you to reconfigure. All these are going to be integrated into a digital platform based on the asset administration cell, and this is what is going to support the information flow between tools that enable you to anticipate external threats, external disruptions, and tools that can be applied directly into the production to do the reconfiguration. So we are a 4-year project. We are now halfway towards the end of the second year. We are in the process of preparing for the integration in our pilots. So this means that very soon an early adopter program will be run. If you follow the Funding Box network, you will be for sure informed about it, where we aim to test as much as possible our solutions to companies outside our consortium, to different sectors, maybe companies with different needs, and see how well we can generalize our approach. So I think that's it from my side. If there are any questions, I'm happy to answer. Yeah.
Thank you very much, Thanasis. Yes, as he said, we will launch the early adopter program for those technologies in 2025. At the end of our presentation, we have a QR where you can join the Funding Box community that Regroup is part of, and you will obviously get updated with once the early adopter program is open. So thank you, Thanasis. Now I will like to introduce to Oscar that will explain the ZDZW project.
Thank you, Maria. I hope you can hear me.
Yes.
Yeah, and also well, thank you, Funding Box, for giving me the opportunity to participate in this session with the Digital Innovation Hubs. Okay, here now I'm representing the ZDZW project that is mainly dealing with this important aspect that many industries face, like producing with the best qualities possible. Hopefully producing, let's say, with zero defect, while trying to keep the production with the minimum amount of resources spent in terms of waste. That is what we call the zero waste. This project, let's say, continue with this, with a big trend of projects that that have been funded in the past in this very hot topic about the zero defect manufacturing. While in this time, where let's say try to continue the process and try to, let's say, bring more impact in terms of sustainability to these industries. Here in our project, our main, let's say, objective is reducing the defects and the generated waste in any kind of manufacturing processes, addressing defect minimization and waste reduction in 3 different key areas that typically cover the entire manufacturing process and the product life cycle. As you can see below, we work on 3 areas, like we improve the monitoring and control for process quality assurance. We also try to, let's say, digitally enhance the rework and repair procedures for part recovery and scrap reduction, because this is even quite important, because many times where you are, let's say, producing really expensive products, wasting them is not really a solution, and you really need to solve the issues, quality issues when they appear, trying to bring them to the market. So rework and repair is also important. And with all that, we try to evaluate what is the sustainability of the process while trying to ensure the best and efficient use of materials and components possible. In this project, you can see with the logos below that we really have a really strong set of partners that typically compare different expertise, not only focus on the different pilot sectors addressing different problematics that different industries may face. Like, for example, we are tackling processes such as plastic injection molding, thermoforming, welding, painting, diffusion hardening, additive manufacturing, and even packaging. So in this project, we will try to bring to the market different innovative non-destructive inspection solutions that would possibly make possible the reduction of waste and test the solutions without discarding the different products. And not only with that, all those set of solutions are bringing to a digital ecosystem where we are able to offer them these solutions in different business possibilities, not only by licensing them or selling them, but also offering different what we call inspection as a service concept, like subscription base or even pay-per-view cases. Okay, next slide, please, Maria. Here in the project, we are offering and trying to bring to the market different solutions that are, let's say, divided into 3 kind of groups, mainly dealing with different quality aspects that may appear in different production facilities. For example, we have an integrity inspection suite that is mainly defined for trying to address on detect, anticipate defects that deals with the integrity of parts, how those parts really can endure the lifetime of their usage. We are also developing solutions in that tackle different aspects about visual inspection, trying to detect different aspects that can be either surface anomalies, volumetric defects, enhanced by artificial vision, or even presented by the usage of AR technologies. Last but not least, we are offering a third suite, mainly dealing with thermal aspects, because thermal can be also really important processes where, yeah, a lot of issues may appear. And it's really important to potentially detect the defects as soon as possible. In terms of the different early adopter programs or beta testing campaigns, we already closed them, and we are, let's say, testing some of these solutions with some of potentially early adopters. But although this may be not really open, we are still wanting to hear from you, and our solutions are being also available in tech funders. So if you are interested in any of them, just can make a contact with them, and we try to organize a meeting with you, because bringing these solutions to the market is really important for us, as we are really committed to innovation. And I think that could be all from my side. If later on you have any question, we can tackle them if needed.
Thank you very much, Oscar. As he mentioned, you can find the ZDZW technologies in the Tech Finders catalog. Our colleague Andrea just linked the technologies in the chat. So if you click to that URL, you will see all the ZDZW technologies available and an explanation of each of them individually. Okay, so the last project that we will like to introduce is Zero Zone. So Purya, the floor is yours.
Yeah, good morning. So thank you very much. Well, let me just start with some explanation. So this, let's say, Zero Swarm project was a project that we started in 2021 under the Twin Transition call. So let me just break down this Twin Transition, let's say, title, so we can understand what was the objective of the project. So Twin Transition means basically from one side, enhancing the digitalization in the particular sector of manufacturing, and at the same time promoting, let's say, energy efficiency, zero waste, let's say, objectives of Green Deal. Let's pack them under one single, let's say, title, right? So to achieve this, basically, we needed to bring together two main groups of expertise. So from one side, mobile technology expert, because the target of the call was about the uptake of 5G and 6G technology in manufacturing sector. So from this side, we have Huawei and some other, let's say, companies that you can see listed as expert in this domain. And from the other side, on the manufacturing sector, we have leaders like ABB. We have also a subsidiary of Schneider Electric and so on and so forth. To first of all start breaking the language gap between the two sectors, to start a dialogue, to better understand each other, because there is a big difference in understanding of even similar words in two different domains. So this was the first phase of the project. The second phase was about the individual technology and enablers development, and at the end, basically this live demo and trials that you can see on the picture. So the project is targeting so-called higher TRL levels, as Maria mentioned. So we are targeting something between 5 to 6 that can be live demonstrated in a group of trials that you can see listed there. So, I mean, in order just to organize these trials, we just group them in basically some groups like North Node, Central Node, and South Node. This is just to facilitate basically collaboration between partners, but nevertheless, technologies developed in one of the nodes can be also adopted and used in the different nodes. The trials are quite diverse. So, I mean, for the sake of saving the time, I will not, sorry, go through all of them, but I'm sorry. It includes the use of, let's say, mobile technology to enable better use of AGVs, which are automated guided vehicles in the factory shop floor, to avoid, let's say, accidents, and also to enhance processes. It includes also the use of, let's say, extended reality technologies in order to do predictive maintenance. It includes remote quality of service management. It enables, let's say, in some cases, we're also testing, as you can see in the North Node, 5G powered PLCs, that the PLCs that are connected to the the 5G. And besides that, the project also has this analytic aspect that I would say like it's equally important, because when we talk about, let's say, adaptation of mobile technology on the factory shop floor, there are always several deployment options. So you can have a network that comes from a mobile network operator. You could have your own network at the other side of a spectrum, but you can have also hybrid modes that might be more cost effective, but you will lose something. And there has been an extensive analysis in the project available just to check on the different, let's say, deployment models. So the project brings different, let's say, aspects, but well, today I'm going to focus on the particular aspect of elements that we develop. If you can go to the next slide, please. So these live demos, to become a reality, we needed to develop some technological items. These technological items are happening in different layers, right? So from industrial automation layer, including asset administrative shell tools or editing tools, or let's say some extra models to activate asset administrative shell capabilities for 5G system, either being the 5G core system or the user equipment or the antenna side. At the same time, we have some tools related to digital, let's say, digital twin, and also cybersecurity tools in this layer. There's a data collection layer that there are lots of enablers there. So you have different, let's say, fronts here, from more traditional solutions to more, let's say, developing solutions like OPSUA and others. And at the connectivity layer, which was the main focus of the project, there has been an extensive work done from different aspects. But now, basically, we group them all. We just pack them in these examples that you can see, like real-time sensor data coming from the different machinery, or AGVs enabled by 5G, or digital twin for the processing processes in the manufacturing sector, and they are available to be offered in our, let's say, early adopter program that has been enabled by Funding Box. You can book a demo, you can get in touch with our colleagues. Just to tell you that basically we have like, let's say 10, 12 key exploitable results that are quite in good shape, that are part of these demos. You can get further information. You can see live demo if needed. But besides, we have also some other, let's say, exploitable technologies that are in a good shape, but they are basically, I would say, maybe in a lower TRL levels, but still, like cybersecurity technologies in different layers, as I mentioned. So when you're talking about privacy and security in the manufacturing sector, especially when you're thinking about, let's say, offering your data over a network, there should be some security measures to be taken into considerations, and these are the tools that we have developed. So I think with this, I can close my presentation. If there is any question or any further, let's say, inquiries about our technologies, please get in touch, and we can discuss it further.
Thank you very much, Julia. So as he said, you can book your free demo in the QR that you can see in this slide. So to summarize, we have a community in the Discord platform where we explain and we give updates of all the projects that we have mentioned. So either you want to understand more information about the technologies of Regroup, ZDZW, or Zero Swans, I would encourage you to join this community, and you will not only find this information about this project, but other projects regarding, you know, technology innovation in Europe. So I would really encourage you to join. And also, if you want to keep update on the new technologies that we release, and all the trends that we and knowledge that we share through TechFinders, this is the QR for joining the newsletter. We send a newsletter bi-monthly where we promote the technologies in the catalog and also the hubs. And you can become part of this network and also promote yourself in this newsletter. So this is the QR, and also the link is in the Google chat. So I really want to thank you for listening to us, and that will be everything from our side. Also, this is my email, so any question that you might have, I'm super happy to answer you. Thank you, Magda.
Thank you, Maria. Thank you, Puria. Thank you, Tanazis. And thank you, Oscar. I feel like now your insights will help us take a bit more sustainable approach to innovation. So thank you for that. And finally, we have Simone, a researcher at the Tallinn University of Technology. So Simone, if you could share your presentation, I will make a short introduction. Simona's expertise is in virtual and augmented reality and digital twin-based applications for Industry 5.0, particularly in the context of human-robot interaction. Today, he'll be discussing how XR applications can transform maintenance and assembly processes in the 5G timber. So the floor is yours. Thank you.
Hello, everyone. Can you hear me? It's
Yes.
audio, and can you see the presentation, most importantly?
Yes.
Yeah, okay. Thanks, everyone, and thanks for the organizers for the invitation in this. I'm, as Magda said, representing 5G Timber project, which is an European Horizon project comprising many partners in the timber industry, but not only across Europe, and in particular Tallinn University of Technology, Department of Mechanical Industrial Engineering, and in particular our augmented and virtual reality laboratory here, which deals with the implementation of augmented and virtual reality applications for mainly industry. I will go through briefly kind of short introduction or overview just to understand the context about extended reality and what does it mean as an integration of real world assets and of course digital informations into the same domain along the spectrum between real and completely virtual environments in what has been already like discussed in the past quite long ago, this virtual reality, mixed reality spectrum somehow, or virtual continuum, and how actually virtual and augmented reality technologies can be seen as or are actually high-end human-computer interfaces in this sense, and how this enables several forthcoming, let's say, visions in industry, including some of the Industry 5.0 understanding of human centricity in the industrial domain. The context of XR in industry, I mean, how does XR support the industrial systems is basically offering safe operation and collaboration between humans and robots in VR. So there is the possibility of having no direct contact with heavy machineries, which are typically or still like closed in cages in some cases. So also the idea of remote operations in difficult environments and harsh conditions. We had actually examples like this also developed here in the university. The possibility of training based on digital twins and of the real machines, as much as the previous slides I showed. So fastening the learning process, optimizing repetitive procedures, or optimizing production processes. Of course, like this repeatability gives the opportunity of using XR technologies and virtual environments as test benches for developing new methods for human-robot interaction and human-robot collaboration systems in the scope of Industry 5.0. And of course, they include the operator in the loop as, let's say, one of the pillars of the Industry 5.0 vision is human centricity. We could see XR as one of the tools where the humans are actually embedded in the digital environment, but still be controlling or visualizing data coming from the real environment and in the loop of the digital twin between real and virtual environment. I will see a couple of examples of systems that we developed here in university. Really simple interfaces for robotic controls. So we have several machines in our laboratory. We have a digital twin of the laboratory itself. And on top of this, we deliver and create even students for their bachelor and master thesis interfaces to control real robots through the network. and to have examples or more flexible interfaces for this. So the human component is essential and is central here. We have the possibility of controlling real machinery through augmented reality. We have been testing this also in user experiments, and of course using different sort of software architecture as a backend for these developments. One of the recent developments was also with another industrial robot, which is even not even sensorized in this sense. So the development here, the idea was creating a path planner for the industrial robot and be able to control it remotely. So the video was made in Rotterdam and the robot was in Tallinn. And we had the opportunity, of course, the robot is not sensorized and we didn't include any safety, let's say, detection of the environment in the XR, which could be eventually done. So the robot has to be anyway supervised by people on site, but still controlled remotely. So how this is getting into the context of the 5G Timber project and timber industry. So the 5G Timber project aims at the integration of course, 5G connectivity into small, medium enterprises in the wood industry in Estonia. So the consortium is much larger, but still like the end users and use cases are located here. And to basically, so one is focusing on the production of sawmill machinery, and the other enterprise is designing and producing wooden house modules, basically for the international market and of course like European and international market. The idea is to leverage local 5G connectivity in-house to support different digital tools for data analysis, for data transferring, development of ad hoc services, which could be related both to the operators themselves, so localization, real-time localization of operator, detection of danger, and to machinery itself, so to assess stoppages in, for instance, some of the sawmill machinery produced by one of the companies or other problematics. The idea is also integrating product lifecycle management software into the companies, but also to track through sensors basically the wood product from the beginning and from the initial let's say production in the sawmill of the raw material till the end, end of life of the wooden house modules, and when these are assembled on site. Of course, the idea is to adopt a user-centric approach and having XR interfaces linked to digital twins of production process and products to enhance and support operators for both two tasks, mainly services and assembly of the product. So I will show the two examples in a moment. We had basically side-by-side work with the companies, with the sawmill machine producer and the wooden house module producer, to determine some requirements of the application. So the applications are developed ad hoc for them, leveraging 5G connectivity on site. The idea in general is having portability of these applications so that it could be used from different devices, not just goggles or headset in that sense to visualize AR, because it's not possible in the actual workplace, but use native handheld devices, tablets, which are already used on site. They should have, let's say, connect to the different services from the PLM in the factory. And they should give also feedback on some of the tasks, of course. Of course, they need to integrate the guidance information for both servicing of the machine and assembly of the wood production and the wood product. The visualization of the 3D components as an advanced, let's say, interactable 3D visualization, but also in augmented reality, and other, let's say, more specific requirements like text-to-speech for the sawmill machinery, or the possibility of reporting non-conformances for the assembly support machine, which actually plugs into the system of the company itself and should also support, let's say, the design to production loop, so that the designers can actually fix the problems and then re-import the models and the instructions automatically. The main architecture for both applications is based on web technology, so WebGL and WebXR, with specific libraries for, let's say, the user interface, and for the backend application itself with dedicated database, which is actually then hosted by the companies themselves. So the first example is the assembly support application for the house modules, which should actually provide a dashboard of the products or the parts and the elements that need to be assembled. It provides a three-dimensional viewer of the part. So this is all like discussed with the company. The module has different parts, like as you can imagine, the floor and different walls and the ceiling, and then a set of instructions which help the operator to follow step by step what are actually the elements that needs to be assembled, and of course which order, and gives additional information about the elements themselves. So a specification of sizes, position that need to be assembled, and of course the opportunity to report non-conformances, and also visualization in augmented reality. So this is again our laboratory. The module itself can be, I will just skip to be a bit faster, can be visualized in real size, and eventually next to the real object can be resized to be able to zoom in and zoom out, or rotate it and understand better the position of the elements, and visualize next to the real object. You can imagine actually this should provide an improvement to the production process, as at the current state, the company is using still like either PDF two-dimensional drawings for the assembly or paper drawings. So the operators, of course, like when a product is produced more than once, they already know what are the procedures, but these are still the supports for this kind of assembly. So we integrated also a non-conformance report form, which includes audio recording, image and videos, which are at the moment not present in the application, and of course, like integrates all the technical problems that are already in the system of the company itself. The application itself has been tested already preliminarily, so we, let's say, went for agile development. So we initially tested with some stakeholders in the company, so from management, IT department, but also, of course, the workers on the shop floor. And it is actually at the moment tested against like traditional ways or supports for the assembly inside in the factory itself. And of course, the goal of the company, but also for ourselves, would be reducing fault report time, the operator training time in assembling some of the modules, lead time reduction, of course, so the total time to produce one module, and of course to reduce in general numbers of non-conformances in the during the production process. The second application is dedicated to, it's actually structured similarly. I will stop maybe. It's what you see now, it will be, it's like an example done in our laboratory, not yet on the real machine, because we are still integrating the data and integrating especially the scheduling of the maintenance from the scheduling software that the company is actually using at the moment. So the application provides like an overview of the maintenance task with some initial visualization of the part of the machines that need to be scheduled in that precise moment, and after a specific time, some safety requirements to be followed, and of course, like a visualization, let's say, and localization of the part to be maintained with, of course, like informations about what to do or what to change there on top of the machine itself, which is based on augmented reality and QR code tracking. So visualization the operator have to. This is meant to improve for operators which have not yet have been in contact with the specific machine, because the specific company here produces the machine, and of course these are then sold abroad in everywhere in Europe. But then the company owners have specific other companies who come and do the maintenance. So you can imagine they might not have been doing the same procedures on similar machines. So this application would help having the same approach for each machine. And of course, also for the company to be sure that the maintenance, the producer company of the machine, the maintenance is done correctly and at the right moment. So what are the criticalities in this sense of, let's say, implementing XR technologies in this context? It's that it's still quite dependent on hardware technologies, including the connectivity and software architectures. So, for instance, we had quite some problem finding some available tablets which support standalone 5G connectivity, which is actually implemented in the factory. It's kind of difficult or takes long time to assess the benefits and revenues for the company itself. And that's what one of the companies for the assemblies, let's say, of the wooden house modules is trying to do. It's quite use case dependable, although we tried in this sense to have a similar software architecture. This has to be, of course, as modular as possible to allow to include functionalities in an easier way, but still it's quite dependable on different type of requirements from the companies. And of course, like in general, XR, if it includes the operator, especially when you access it, not just through a tablet, but through headset, it has like some privacy and cybersecurity concern and ethical issues on that side. That's it from my side. Thanks a lot. So you can actually check more of our work as a university research group at our website and our laboratory website, and of course more information about the project itself on 5G Timber at the specific project website. Thanks a lot.
Thank you. Thank you, Simone, for showing us how the XR technologies can shape actually the future of manufacturing today. As I don't see any questions right now, I'd like to thank you again to all of our speakers for sharing their insights with us today. I think that was a truly rich session, if in many new knowledge and facts, and I'm sure that we all gained some new knowledge. Yes, and if you have any questions for our speakers, you can submit them on chat, or if you have any questions later, you can find the emails and presentation later in the recording of the webinar, and we will share as well with you them via email. So don't be afraid and just ask questions if you need anything. Yes, so I think thank you again to everyone who joined us today and also who joined us during our previous sessions in the Roadshow with the DIHs series. I will now stop the recording